You can take out your highlighter again, and we're going to look at the quotient of functions. And again, there's nice notation. I would say this is probably the nicest notation you could write. Whoa. F of x divided by g of x. So anytime I would have anything, I would change the notation to look like that. Okay? Not nice notations include this one, f divided by g of x. Sometimes they have this notation. Also not nice. So again, whenever you can, change the notation to this. So if you saw f divided by g of 2, I would change it to write as f of 2 divided by g of 2. And then we can look at our functions. We know that f of 2 is 2. We know that g of 2 is -1. So when we divide them, we get -2. Now, the reason that dividing is done differently or is done separately is because we have the situation where you could be dividing by 0. In this case, g of x is the blue graph. It's in your denominator. F of x is in your numerator. So there could be a problem if g of x is ever equal to 0, because then you would be dividing by 0. And sure enough, g of x is equal to 0 at 1. So we would have in this graph an asymptote at x equals 1. And after figuring out a bunch of values, and you could do more than one, you will get the following graph. It approaches the asymptote. This is an easy point to figure out, because wherever your numerator is equal to 0, 0 divided by anything is 0. Wherever the two graphs intersect, that's where your graph is going to equal 1. And since there's an asymptote, your graph would need to have asymptotic behavior. Now, the domain for f of x is x is bigger than 2. The domain for q of x is x is bigger than or equal to 2. In addition, x can't equal 1. So this is the new thing with dividing. You still have the overlap of the two domains, but you might have to add some non-permissible values as well. So when we go to example 2 now, we've got f of x is the square root of x, g of x is x minus 2. Once again, I will color code these, f of x in red, g of x in blue. Do a quick graph off to the side. The square root of x, 0, 0, 1, 1, 4, 2. And g of x y-intercept of -2, slope of 1. It would also have the point 4, 2. Excuse me. So state the domain and range of both of those. For our red graph, the domain is bigger than or equal to 0. The range is bigger than or equal to 0. For the blue graph, the domain is everything. The range is everything. And now we want to graph q of x in green, where it's f of x divided by g of x. Again, we're going to divide y values. And wherever, right, g of x is on the bottom, so wherever g of x is equal to 0, that's going to be a non-permissible value. And sure enough, it's equal to 0 at 2. So we'll have an asymptote at 2. We can do other values. For example, 0 divided by negative 2 will be 0. Here we would have negative 1 divided by 1. Sorry, 1 divided by negative 1 will give us negative 1 towards the asymptote. Here the two graphs intersect. That one will be equal to 1. We could take another value here. Here our blue graph is equal to 1. So when you divide by 1, what's going to happen? The red graph would stay the same. And this section of the graph will look like this. It can't go into the negatives because both the blue and the red graph will stay positive in that section. And a positive number divided by a positive number will stay a positive number. The explicit equation for q of x would equal the square root of x divided by x minus 2. Its domain would be x is bigger than or equal to 0, but now x can't equal 2. And its range this part of the graph approaches an asymptote at 0. Okay? A little bit that you could take from your rational functions unit. I could rewrite this as x to the half over x minus 2. Can you see that the degree is larger in your denominator? It's x to the 1. Your degree in your numerator is x to the half. And from our rational equations unit, whenever the degree was larger in your denominator, you had an asymptote at y equals 0. However, in this case, y is the range everything if there's an asymptote at y equals 0. Well, we do have the point 0, 0. So we would include 0. We have all the negative values. And with the asymptote, we have all the positive values. So putting that together gives us a range of everything. Questions for practice on this one are 6, 13, and 16.